Hello guys and welcome back to my video. So in this video we are going to be using machine learning to detect if an email is a spam or not, right? So guys, I think you have noticed that when you be using your Gmail, right? Some emails are automatically categorized as spams, especially if they have suspicious ads or malicious intent, right? So in this video, we're going to be using the multinomial naive Bayes to to detect if an email is a spam or not. And then in the next video, I'm going to be deploying it into a web application using Flask, right? So without further ado, let's get started. So the first thing that we are going to do, we are going to import our dependencies, right? And then we are going to read our data set from memory, which is the spam.csv. And then our encoding is going to be Latin 1, right? And then we are going to use the df.head to visualize the first 5 items in our data set. So if you are not familiar with pandas, I urge you to go and watch my video on pandas 0 to hero, right? So now, as you can see, our data set, we have v1, which shows 0 if it's a hem, and then it's a spam, it's showing hem, spam. And then the other thing we are going to show, we have these features called unnamed 1, unnamed 3, and unnamed 4. And these features, as you can see, they don't have values, so they are not useful in our data set. So we are just going to drop them using the dot drop object from pandas, right? So we are going to drop them. And then now we are going to be left with only v1 and v2 as our features, right? So the next thing that we are going to do is we must visualize the distribution of our classes, right? As you can see that, as you can see, okay, I made a mistake. So as you can see that in this case, I made a mistake in this case. Sorry. Yeah. As you can see that from our data set, we can see that we have more, our data set is an imbalanced data set, right? We have more emails that are classified as spams and less emails are classified as spams, right? More emails are classified as spams and then less emails are classified as non-spams, right? As you can see, this is the distribution of our data set. Sorry, so more emails are classified as non-spam and less emails are classified as spam. I just this was just a mislabeling. Right? As you can see that hem classes that are non-spams, we have more examples that are non-spams and less examples that are spams. So this creates an imbalance in our data set so that our model, if we train our model using this data set, our machine learning model will always be biased on the non-spam examples, right? So to fix this, what we are going to do is we need to see how many items are spams. As you can see, we have 747 items as spams. So now the next technique that we are going to use, we are going to use the random undersampling technique. So the random undersampling technique is a technique we use uh, to reduce the features with more examples so that they can be equal with features with less examples, right? So what we do is we are going to create a subsample of our data set. We are going to use df.subsample is equals to df.sample. And then what we are going to do is the spam df is supposed to be df.subsample. And then we are going to check if uh, our our target variable is equals to a spam, and then non-spam df. We are going to check also if it's not a spam, and then we are going to select only 747 examples from these non-spam examples so that they can be equal to 747 spam examples, right? Now what we are going to do is we are going to store them in a variable called normal distributed data frame is equals to pd.concat. We are going to concatenate the spam data frame and the non-spam data frame, right? And then the next thing that we are going to do, we need to shuffle them, right? So our new data frame is called to be the normal distributed data frame dot sample. We are going to shuffle the data set. The random state is equals to 42, and then let's visualize it. Now we now have equal classes. So if we are going to check now our distribution, we can see that non-spam and non-spam classes are now equal, right? So now what we are going to do is for our features, right, that we are going to train our model, we are going to use the V2 feature, which is this one, the V2, right, the V2 feature. And then for our label, we are going to use y is equals to be the label, as you can see. Y is equal to the label. And then we are going to initialize the count vectorizer. So what the count vectorizer does is going to map the words into vectors, right, a number. It's going to map a number and a word, right? Because since our machine learning models understand numbers, so the we need to feed the words as vectors, right? A vectors with a number and words, right? And then we are going to say x is equal to cv dot fit transform. We are going now to fit our data set, right? Now what we are going to do is we are going to split our data set into x train, x test, y test, y train, y test, goes to train test split x, y. Our test size is going to be 0.33 of our data set. Then random state is going to be 42. And then our classifier is supposed to be multinomial naive Bayes. And then we are going to fit our classifier, our training data set with the multinomial naive Bayes. And then we are going to calculate the score. And then the predicted y value is supposed to be the classifier dot predict our x text, right? And then we are going to print a classification report. As we can see that our model is doing well on the precision, recall, and also the F1 score. Now what we are going to do is we are going to import the job lib, and then we are going to dump our trained model into memory, right? So this model that we have dumped into memory, we are going to use it next time to deploy our spam detection module into a web app. So thanks for watching, guys. Cheers. Make sure you click the like button and you share my video, and also click the subscribe button so that you don't miss any of